All right, so circumference is, perimeter of a circle. And the formula was what for circumference? No, 2 pi r. Good. And then for area is what is inside, the area inside a circle. And what was the formula for that? Pi r squared. And those you learned in elementary and middle school. It's been a while, but you did learn that. What we taught, or what we learned yesterday, hold on, let's do this question real quick. How would we calculate the circumference in the area of a circle with a radius of 8? So what does this radius of 8 tell us? 8 is my r. And so how would I figure out what the circumference is? I'm going to just bring down 2 pi, and instead of r, what am I going to write? 8. When you are doing the work for this, you are not putting pi in the calculator. You are going to just put it in your answer. So what is 2 times 8? So my answer is 16 pi. And that would tell me the perimeter of a circle with a radius of 8. How would I find the area? Pi r squared, but instead of r, we're going to do, does anybody know what 8 squared is? What? 32. Not 32. That's 8 times 4. What's 8 squared? 8 times 8? 64. So this is 64 pi. And that tells me, if I were to shade inside a circle, how much I'm shading. Do you agree y'all learned that before? Yesterday, what we were supposed to learn is something called arc length. And what arc length is it is just part of the perimeter. So instead of finding the perimeter of the entire circle, arc length is saying, hey, what is just this piece right here? Think of it as a piece of pizza crust. Any of y'all just eat the pizza and not the crust, and you leave the crust on your plate? That's like what that is. You already know, y'all learned last couple weeks, that if I know the angle, do you agree? Whatever the angle is, that is my degrees of my arc. Y'all learned how to measure the arc as far as in degrees. What this does is measures it in inches or feet or meters or whatever, centimeters, whatever units they use. So this tells me the actual distance if I were to get a tape measure. Okay, I was showing last period. Is it still up? No, it's not up. I was showing last period. Y'all know a stoplight, red light, yellow light, green light. Have you ever looked at a stoplight? On the top of all stoplights, there's like a little, what would you call that? Shade? Yeah, like a cover. Do y'all know why they have those covers? So you can see it, so the light doesn't hit it and like reflect. So that shade right there, that's kind of like a representation of arc length. How much, that's when they would use it. They had to figure out the arc length to figure out the measurements of those and different things. Does that make sense what I'm saying? Okay, so this right here is the formula to finding that arc length. You do the number of degrees over 360, because it's just part over the whole. And then this right here is the what? Circumference. Okay, so that's what we're doing for this first problem. So it says determine the arc length of arc CR. So it wants to know how many centimeters is CR right here. Well, the formula again is x over 360 times 2 pi r. Box that formula so you can find it easily tomorrow. So what's my x here? 120. It's my degrees. What's my radius here? What's my r? Nine. And then from here, I think what really confused y'all too is he started reducing and dividing in his head and just writing it all up there. Just put it in Desmos. Just put it in Desmos. So in Desmos, what I'm going to do is I'm going to write exactly this. 120 over 360 to, am I going to put pi in my calculator? Do not put pi in the calculator. It'll be in your answer. And what, not S, why did I put S? 2, and what is my answer? My answer is not 6. What's my answer? 6 pi. So that arc right there is 6 pi centimeters. Does this make more sense now? All right. The other thing that we learned yesterday, can I move on or are y'all still writing? Okay. The other thing that we learned yesterday is sector area. So what sector area is it is telling me how much piece of pie or piece of pizza is shaded. The area there. And it's almost the same formula. It's not the same formula. You're still going to do x over 360. You're still doing part over whole. But this time, what is this formula right here? This is area of a circle. So you're going to do pi r squared instead of 2 pi r. Your x is still going to be the degrees. Your r is still going to be what? The radius. Okay. So going back here, question 5. Find the sector area. It's going to say something about sector area or area of the shaded or something like that. You are going to do x over 360 times pi r squared. And what is my equation going to be when I plug in here? What am I going to get? 120 over 360 times pi 9 squared. Because my r is still 9 and my x is still 120. And then this time when I plug it in, 120 over 360. I'm not going to put pi. I'm just going to do 9 squared. And what do I get here? 27 pi is my answer. And because this is area, it'll be centimeters squared. Does that make sense? I want you to try number 6 on your own. Go. I'll give you about 1 minute to do number 6. It's just setting up. It is not, you don't need your Desmos for it. What could you eliminate right off the bat? Which one? Just looking at them real quick. What can we eliminate right off the bat? Why B? It is 180. Are we dealing with 180 at all? No. Now, that's even before I read the question. It does tell me that the central angle is 100. So it should be 100 over 360, but that doesn't help me eliminate anything. It also says which expression can be used to calculate the area of the shaded region. Which formula am I going to use for area? Which one of these is with area? Pi r squared. So what does my answer have to have here? Squared. So which can I eliminate? C and D. A is the answer. Does that make sense? Any questions? I want you to do number 7 on your own. Go. You are going to get decimals. That's okay. Do number 7. Go. now is a great time to ask questions if you're not understanding. Almost all the way. No, there you go. Now you can. All right. So for this one right here, what is my x? What's x? 36 over 360 times, and this one's arc length. Which formula do we use for arc length? 2 pi, what's my r? 8. And then what do we do from here? Just plug it in. So then I'm going to get 1.6 pi is my answer. And there's no units, so that's it. Is this making more sense? All right, what about for area of the shaded sector? Again, what's my x? Over 360 times, and then what formula am I going to use this time? The squared one. Pi r squared. And then plug this into not 9/8. And I get 6.4 pi. If it's a pretty decimal like 6.4, 1.6, 2.8, I'm fine with it. But if you were to get something like, okay, I don't think you'd get an ugly. If you were to get something like this, y'all see how that's a repeating decimal right there? Y'all see how that's disgusting? I don't want you to round your decimal. If you have to round your decimal, just give me the fraction. Okay? So if you get an ugly decimal, I want you to just give me the fraction instead. All right, that is all we are going to do on the back. I need you to now flip to the front. This is more so what your assessment tomorrow is going to look like. All right, so the problem, anybody want to read the problem for me? There we go, loud and proud, read it. You got it, Leslie. Yeah.
Miss Nelson has 500 students that she teaches. 75 are passing with an A, 200 with a B, and 150 with a C. 75 are not passing. If she creates a pie chart with the radius of 3, clearly the proof of the
Cool. What are my categories? Anybody want to guess? A, B, C, and what's the last category? Not passing. Okay. Now, how many had A? $75. 75 are passing with an A. 200 with a B. How many with a C? And not passing is? How do we find the percentage of people here? How do you find the percent? What'd you say? No. How do you find the percent? What is the percent of A's that she has in her class? What would you do? Just think logically. How do we find percent of something? It's out of 100, right? So what we're going to do is, how many A's does she have? 75. Out of how many people does she have? How many? She has 500 students. Do y'all agree 75 out of her 500 students have A's? Now, I want a percent though. So in order to find a percent, 75 out of 500 gives me 0.15. What am I going to do to find the percent of that? Say it again. Times what? Times 100, because it's a percentage. So times 100. Or you could just move the decimal 2 times. Same thing. That's timesing by 100. So 15% of her class has an A. How many have a B? 200 out of how many kids? And then how do I find the percent? Do what? Multiply by 100 or move the decimal twice. Okay, I'm going to have you finish C and D in just a minute. We're just going to do A and B for now. Okay? Next question wants to know, how do you find the central angle of a circle? So at the top when Leslie was reading, it says she's going to create a pie chart with a radius of 3 and graph it or plot it or whatever. So how do I find out what each angle, how many degrees each angle is going to be to make the pie chart? Well, what do I know about her A's? 15%, right? And do y'all agree it's 15% is 15 out of 100%? Y'all agree with that? Yeah. And how do I figure out how much of that is a circle? What is a whole circle? Times 360. Because a whole circle is 360, I only want 15% of that. So I am going to do 15 over 100 times 360. And how many degrees is that? That's going to be 54 degrees. So your answer here, this is an angle, it needs to have a degree. I also want to show you another way somebody showed me last period in Desmos. You can literally write 15% of 360 and it'll tell you. That's a cool little thing Desmos does. But, so what am I going to get for the next, for the B's? How many percent are B's? So 40 over 100 times 360 is or I could say, what is 40% of 360? It is 144 degrees. Is this making sense? This right here is my central angle. So, I am going to have to come down here and measure that to graph or draw this pie chart. So when you're doing this, please make sure your protractor is in the right direction. You are going to put this hole on your center. And then do you see this line down here? You're going to make sure that it is in line with this right side right here. And how many degrees are my A's? 54. So I'm going to go, 0 is on the inside. I'm going to go on the inside numbers. And I'm going to plot what I think is about 54 degrees. And then these are my A's. And if you read the instructions right here, it says use a ruler, measure accurately. Inside each sector, label the category name, A's, the percentage. What percent were my A's? No, percent was 15%. And the central angle. What degrees was this? It was 54 degrees. Now I need everybody to watch. Look up real quick. If you don't have a protractor, that's fine. There's some missing. We didn't have enough. We'll pass them around in a second. To do the B's, look at me, please. You are now going to turn your paper, and that line you just drew is now going to become the line that that you should line up to right here. And then how many degrees were B's? So on the inside, I got to now go to 144 degrees, which is like way over here. And then connect it to this from the center. And this is my B category. Do I have any questions so far? And then y'all will do the same thing with C's and D's later. Who doesn't have a protractor? Raise your hand. 1, 2, 3. Okay. Did they run out back there? If you're sitting next to somebody who doesn't have one, when you're done, can you just pass yours to them? Because we don't have any more, unless they're on the floor, but I don't think so. All right, we're going to come back to this. I want everybody, we got 2 more columns to fill out real quick. The next column is my arc length column. Arc length is what we were just talking about on the other side. So right here, I'm going to write, by the way, if I haven't said this already, you get to use this tomorrow. Make sure you're taking good notes here. X over 360 times 2 pi r. What does my x stand for? What does x stand for in this formula? Degrees. Where did we just figure out the degrees? Y'all, this column right here is the x. So you are going to use whatever you got in the column right above it for the x. What about my r? What does r stand for? Radius. What is my radius? No. Read the top. It told us at the top. What did it tell us the radius was? It said it has a radius of 3. So for all of these, what's my r going to be? 3. So for like section A, I'm going to do 54 degrees over 360 times 2 pi, what's my r? And put that in the calculator. What about for the B section? What am I going to do? 144 degrees over 360 times 2 pi r. And put that in the calculator. Remember, don't put pi, but your answer needs pi. So my first answer should be what? 0.9 pi. And then what's my second answer? 2.4 pi. What questions can I answer about what we're doing? Is this making sense? Last but not least, the section asks for the area of the sector. How can I find the area of this sector? Say it again. Pi r squared. So I am going to do x over 360 times pi r squared. Again, where am I going to get my x from? 2 columns up. It's not going to be the one right above it this time. It's still going to be the same degrees. So you're still going to have 54 degrees over 360, but this time you're going to do pi, and it's still going to be 3. And then put that in the calculator. and I get 1.35 pi, and I get 3.6 pi. I would like you to finish the last two columns and then do the table on the bottom, or the pie chart on the bottom. This is what your assessment looks like tomorrow, what you're doing. If you have any questions, now is a really good time to ask me. Finish it. Thank you. Bye.